So in the today's class, we're going to see the numericals on the Ohm's Law, KVL, KCL, and voltage divider technique and the current divider technique. So this is the very simple circuit of different R1, R2, and R3 has been given, which are connected in series, and the V is some voltage is applying here. The current is 1.5 ampere is going through the series resistors. Now they are asking us to calculate the supply voltage. So we need to calculate the supply voltage here. So this is the current is flowing at every moment here 1.5, here also the 1.5, and here also 1.5 is the current is flowing. Why in every element is 1.5 amperes is flowing? Because these three resistors are connected in series. Now according to apply the Ohm's law here, apply the Ohm's law and write the what is the relation at this particular resistor here. So this is 2 ohm resistor is given to us, and 1.5 amperes current is there, and V1 is there. So if you want to find what is V1 here, V1 is equal to, I can write 2 into 1.5. So this is equal to 3 volts. So this is what I am writing. Now similarly, if you calculate what is the voltage across the second resistor, so you can say that V2 equal to the current flowing through this 1.5 amperes into that resistance 3. So you can write it is the 4.5 volts. Similarly, you take this one and you can calculate what is the voltage here, V3. This is the R into this 1.5 amperes current, so it is coming 12 volts. But my actual question is to find what is the voltage, supply voltage. I need to find what is the supply voltage I need to find. So this is, you take this is the plus and minus, current is going in this direction, so you can write plus and minus, plus and minus, plus and minus, and start from this circuit here, and you can assume it is a closed circuit. Then apply the KVL here. Now apply the KVL and write what could be the equation here. I can write this is minus V plus V1 plus V2 plus V3 equal to 0, or V is equal to V1 plus V2 plus V3. So what is V now? It is nothing but the 3 volts plus 4.5 volts plus 12 volts. So it is nearly 19.5 volts. So this is my answer. So in this case, two laws we are going to applying here, that is Ohm's law and as well as KVL, in order to find what is the voltage across all these resistors. So you need to understand one more concept here is called the total power. Calculate the total power. If I say this power, calculate the power. So as we know that what is the power definition, we have already seen that power definition is the rate of energy consumption in a electrical circuit is called that power consumption. That is the expression we have already seen. This is also can be written as V into I, or you can write it as I square R equal to V square by R. So these are different expressions we have in order to calculate the total the power in any circuit. So in this case, I need to find what is the total power consumed by this circuit. What is the total power consumed by this circuit? So for this, I need what is the total voltage, what is the total voltage supply in here. So this is nothing but 19.5 volts is there. What is the total current here? The total current is same. The total current is same, that is I is coming like this 1.5 amperes. So what is the total power now? The total power PT can be taken as 19.5 into 1.5 is equal to 29.25. This is what you can write watt. So this is I'm writing now. Suppose if I wanted to calculate what is the power dissipated by this particular resistor, what is the power dissipated by this resistor, and how are you going to take. So this PR1 at this power dissipation, I can use any one of these formulas. So V and I. So what is the V here? What is the V here? We already calculated 3 volts. So I can write 3 volts into what is that I here? What is this I? I is flowing through this resistance is 1.5. Then this is coming like 4.5 watts. Otherwise we can take another more expression here. So this is what I am used here now. I can take this one also, I square R. So what is here I square? The current 1.5 square into R. What is R here? R is 2 ohms. You do this one also, you're going to get 4.5 watts. Otherwise you can take the one more expression here, V square by R. V square by R. What is the V at this particular resistor? That is 3 here. 3 square by R. If you do this one, 2. So this is 9 by 2. Again you are getting 4.5 watts. So this is how you can verify that these three relation for that your power expression. So similarly, can you calculate what is the power here? We can calculate because you already know voltage, current, and resistance also. You can use any one of these expressions and you can calculate. Similarly, also you can do for this one. So this is how we are going to calculate the power. This power is nothing but a DC power. DC power, because we are studying that circuits in DC circuits. So whatever the power we are calculating is called the DC power, PDC you can call. So this is the another circuit has given to us. So again R1 R2 are connected in series with different resistance values as given to us, and supply voltage V is also given. Supply voltage 100 volts has been supplied here for this circuit. So this is what given in the question. They are asking to find what is this current flowing through this. So this is this is what I need to do here. So as we know that you can make it as this circuit into the equivalent circuit of this. Can I make it something like this? You can make it, yeah, it is 100 volts and I'm making as, and this is my current. What is the R equivalent circuit here? R equivalent, because these three R1 R2 are connected in series, so R equivalent can be written as R1 plus R2 plus R3. So this is the expression. 40 plus 50 plus 70, what will going to get here? So this is the 160 ohm we are going to get. Now can you calculate what is the total current here? What is the total current here? So I total can be calculated as the voltage by that R equivalent. You can calculate. So what is given here? So this is 100 volts is given to us and R equivalent is 160. If you do this, you are going 0.625 ampere. So this is what the current is flowing through here. So now I know the current is flowing in all the resistance, 0.625 amperes, 0.625 amperes, like this, 0.625 amperes. Now if I ask you to calculate what is the power here, what is the power here at the PR1, can you calculate? You can do it. Similarly for this, if I ask you to do PR2, what is the power here? Can you do that? You can do that one also. And similarly, you can do that PR3 also. So that is what you can, because already you have know the current and the resistance, you know. So that is I square R is the formula. You can apply it and you can calculate what are the powers dissipated across all these R1, R2, R3 elements. So this is what we need to understand in this numerical. Now we're going to talk the concept of the voltage divider technique. So this concept we already taught to you, and I want to do one numerical on this. So I will take different resistor which are connected like this, and here the supply is given this 30 volts and resistance is given 200 ohms and 100 ohms is given to me, and I need to find what is V1 and what is V2. So that is what I need to do here. So I want to find what is V1 and what is V2. So this is what is asking to find. So for this, what you're going to do here, so can you, these two, suppose the current I is flowing like this. So this is the same current is flowing, these are the two are in series. So I can write R equivalent is equal to this 200 plus 100, you can take it is as 300 ohms. So this is what my circuit now. So 30 volts is there, and this is 300 ohms resistance, and I need to find what is I here. Can you find this I also here? Of course you can find. This is the V by 300. If you do this one, you're going to get, so this one 1 by 10 amperes is the current is flowing through this circuit. Then if you want to find what is the V1 here, so V1 is equal to this resistance into this current 200 into 1 by 10. If you do this one, you are going to get 20 volts, and V2 is equal to that 100 into 1 by 10 amperes, that you are going to get that 10 volts. So these are the V1 and V2 across these two resistors. So this is what the solution I did by applying some equivalent circuit concept, and by applying some Ohm's law concept here. But I does not want these two concepts. I need to apply, and I want to apply the voltage divider technique, and I want to find what is V1 and V2. So that is what. So you already know that if the two resistors are connected in series, and this is the V supply is there and R1 and R2 are there, and if you want to find what is V1 and V2, so V1 can be taken as the formula, the expression already we have derived. So V1 can be taken as the supply voltage into the same resistance where we want to find the V1 by the total resistance, sum of the total resistance. This is the formula. Suppose I want to find what is V2 here, then again the supply voltage into where I want to find V2 at the resistance R2, so R2 by R1 plus R2. So these are the two expressions you can derive for the voltage divider technique. So use these two expressions and you can calculate. So what is the V1 now by using voltage divider technique? So what is the source voltage? 30 volts into the resistance, that is 200 by the say adding of these two, that is 300. You can take, do this one, if you do, then you are going to get, this is what, 20 volts. If you take the second one, V2, and do this one, apply this form for this formula, you do this one, you are going to get 30 into 100 by 300 is going to get 10 volts. Do this one. So this is what the same value you are getting here also. So this is by using the voltage divider technique, we are getting the V1 and V2. This is by applying some general solution. It is what we have done, the general solution by using Ohm's law and KVL and KCL. You can also find. So this is you can need to understand what is this voltage divider technique, how you can easily apply to that any circuit. Now we will see the current division technique. current division technique, which we already seen, divided rule, current division technique or current divided rule. To understand this, so I'm considering the two resistors which are connected in parallel here, and this is the voltage has been given to us, and some I is there, and I1 and I2 is there. So this is what they're given to us, and here, so I can write this, the total current also they have given 7.5 amperes. So I need to find what is V1 and what is I1 and what is I2. If you do the generalized concept here, so by using any common sense, that by using up Ohms Law and KVL and KCL, you can see here. So I'm not using this one. I will use this technique later. I will generalize using some concept, and I will find what is I1 and what is I2. So see here, whatever the voltage which is supplying to this particular this circuit is in parallel with this. So whatever the voltage 110 which is connected to these two resistors are also same, isn't it? So because they are connected in parallel, so whatever the voltage which is supplying is will appear across these two elements R1 and R2. So I can say these are the 110 volts and 110 volts I can write. So what is I1 now? I1 is equal to whatever the voltage 110 by this R1. What is the R1 value is given here? It is 22 ohm is given, and R2 is given 44 ohms. So you just take it 22 ohm, so you'll get 5 amperes. So this is what. But what is I2 here? So again 110 volts by 44 volts are going to get 2.5 amperes. So this is what. If you want to write what is I is nothing but what? I is nothing but I1 plus I2. So what is I1? 5 plus 2.5. If you do this one, you are going to get 7.5 ampere. So this is also verifying the KCL. So this is also verifying the KCL at this node. So this is what the meaning of this. Now come back to here. What is the current divided technique is that I will reminding you once again what is the technique and what is the formula we have seen. So this is I1, this is I2, R2 and R3, if it is like this. And if you want to find what is I1 here, what is I1, then we have to take the whatever the current is flowing, the total current is flowing in the circuit into, so where I want to find I1, so I am not going to take this resistor, I will take that which is connected opposite to this resistance. It is like the R3, I will take by the total resistance R1 plus R2. This is what the formula. Try to recall this. I2 is nothing but again the total current I into, so this is where I want to find the current. So I will take this resistance now, R2 by R1 plus R2. So these are the expression you are getting from the current divider technique, current division technique. Now apply these to I1 and I2, you can find what is the current I1 here. So I1, what is the total current is 7.5 amperes into what is R3 here. Sorry, this is R1, this is R2. Okay, so this is R2. Okay, and this is R2. Yes, this is fine. Okay. Now Y1, what is R2 here? I can take this R2 is 44 volts. This one by the total resistance, this 22 plus 44. If you do this one again, you will get this current 5 amperes. Do this one, you will get that one. And what is I2 here? Again 7.5 amperes into, so this resistance 22, this is what, this is R1, and the total resistance 22 plus 44. So if you do this one again, you will get 2.5 ampere. This is what you are going to get here, isn't it? Yes, you need to understand these two concepts to calculate that current. So here, if you remember this voltage division technique rule, you can apply these formulas directly and you can calculate. Otherwise, you have to follow your standard rules. Use the Ohms law, and the KVL and the KCL. You need to remember and you need to apply, and you have to calculate these particular parameters here. So here we're going to see some KVL application in the circuits. So if I give this circuit to you and asking to apply the KVL, so what you're going to do, so this is the already for this element the polarity has been given, and for this element also the polarity has been given. For the remaining elements we need to identify the polarity here. So already in this problem, that already the direction of the current is given. So this is what the direction of the current is given to us. So if the direction of the current is not given, you can also assume that direction, so according to you. But in this problem already the direction is given, so this is what the direction is already given. We are assuming that one. So and for this, whenever this current is going in this direction, so I am assuming this is plus and this is minus. Here already that polarities is assigned, so I am not going to assign the polarity here. For this there is no polarity has been assigned, so this is the direction of my current. So I will assume plus and minus, and for this also I can assume plus and minus. So this is what my polarity. Now at each and every element the polarity has been assigned. So remember, if that polarity is already assigned to any element, so no need to do any polarity assignment. If not, then you need to do the polarity assignment according to your current direction. Current direction, you can assume the polarity. So whatever the polarity you are assuming, it could be the uniform for all the elements. So for this element, current going plus and minus. For this element, current going through this plus and minus, through this plus and minus. This is what my convention I am considering here. Now if you apply the KVL here, so I will start from this point. So I can write minus 2 here plus 1 ohm into 1.5 amperes. This one plus 1 volt. For this plus 1 into 1.5 amperes. For this again plus 1 into 1.5 amperes. So this is what we need to write as the KVL. So you just go through it and carefully do some more number of numericals on this KVL. So you need to understand how to assign the polarities here. So this is what. Now come to that next question here. So this is what the diagram has been given to me, and they are asking me to find what is the voltage across the R2 resistance. So what is the voltage across this resistance they are asking me to find. So I have to see that here. So this is my current direction is already given to me. So this is what my current is flowing like this, like this. So for this element that sign is already provided, and for this element also, for this source also already this polarity has been given. So I need to assign the polarity for this one and this one. So I can take this was the plus and this minus. Similarly, when a current is coming like this in this is plus and this is minus. This is what the polarity I am assigning here now. Now apply the KVL here again. Apply the KVL in this circuit or in this loop here. So start from here. So this is minus 2 volts. What about this one? Plus I can take. So this is already voltage has been given at this resistance. I can take 1 volt, and this is the negative 3 volts, and here I need to find what is the voltage. So it is the plus. What is the voltage we have to find? VAB. So VAB equal to 0. This is what I am writing here, and VAB you can take it as, so this one is, I think you are getting the 4 volts. So this is the answer you are getting from this circuit. Now we'll go for the next topic is called how to find the equivalent circuit. So as you already seen, I will see some examples here. So this is what is given to me. At the AB terminal, I want to find what is the R equivalent. So R1 and R2 is there. So this is the network is given. They are asking to in between this terminal. From this terminal, I need to see towards this particular circuit, and I need to find what is the R equivalent. So you already know that. So from this A point, you have to define what is the current direction. So this is going like this is going like this, so this is coming back like this. So if the current is flowing in these two elements are same, so if this current is flowing through this R1 R2 is same, so I can assume that I can say that this R1 R2 is connected in series. So what is the R equivalent for the series elements? R1 plus R2, isn't it? So what is the equivalent circuit now? I can make it as the equivalent circuit like this, and AB terminal, my R equivalent, this one, that is nothing but R1 plus R2. This is R equivalent. If you see from between the AB terminal, that is the R equivalent you are going to get. Similarly, you just see here, suppose the two elements are connected in parallel like this, and AB terminal is there. Now I want to find what is R equivalent here. What is R equivalent here? This is R1, this is R2. Again here, you need to assign the current directions here. So from A point, I start the current. This is my current I is going like this, but when it comes to this point, my current is divided here. So I1 and I2. It means that when the current is divided, so in the two elements, so I can conclude that R1 and R2 are connected in parallel here, and coming here these two currents and coming back to I. So I is equal to nothing but I1 plus I2. So that is why, so same current is divided here and coming through these two elements and coming back the same current. So in this aspect, I can say these two elements are connected in parallel. These two elements are connected in parallel. And what is R equivalent? You can say, what is R equivalent? This expression we already derived. If the two elements are two or more elements are connected in parallel, then R equivalent, that is 1 by R equivalent, 1 by R1 plus 1 by R2. This kind of expression we have derived. It can be go up to a number of elements which are connected. So this is R equivalent. If the two elements are connected, you just simplify this equation. You will guess R1 by R2, R1 into R2 by R1 plus R2. So this is what we are going to get, R equivalent. Then what is the equivalent circuit you can draw here? So this is my equivalent circuit A and B. If you want to find what is R equivalent, that is nothing but R1 R2 by R1 plus R2. This is what we are going to see. So this is the one more circuit has been given, network has been given, and they are asking us to find the R equivalent across the AB terminal. So that is what the question here. So again, from where the point I will start my current, I assume that I is the current is flowing like this, At this point, my current has divided. So this is, I can take, this is some I1 and I2. Again, this current is coming like this. So this is same current is flowing here and coming back here, and this is what my current I2, and this is what my current I1, again coming back the total current. So this is what the current directions I assumed from A terminal to the B terminal. So A terminal to B terminal, this is my current direction I assumed. From these current directions, I can find that which are the elements are connected in series and which are the elements are connected in parallel. So if you start from here, in the R3 and R4, the same current is flowing. In the R3 and R4 the same current is flowing, so I can add these two elements. So I can add these two elements, that is, you can say Rx is equal to R3 plus R4. So this is the value for this particular branch here. Now redraw the circuit now here. So this is my circuit now I'm drawing. So combining this, I can take only the one resistance here and A and B. This is my R1 and this is my R2. Now what is this one? This is nothing but Rx. This is nothing but Rx. What is the Rx value? R3 plus R4. So this is what I'm taking this now. Now come back again here. So this is my current again. I is coming like this, coming like this. Here it is again divided. So this is going like I1 and this is going like I2 and coming back here. So whatever the current I1 and I2 which are flowing through this and coming back the same current. So at this moment I can take R2 and Rx, both are connected in parallel. These two are connected in parallel. So this is the understand the concept here. R2 and Rx are the connected in parallel. So if the two resistors are connected in parallel, then what is the formula? Let us take Ry is nothing but I can take R2 into Rx by R2 plus Rx. So this is what the I'm considering the formula here. This one. Now I will get that some value Ry here. Now I replace these two elements with this Ry resistance here. Then what is the equivalent circuit you are going to get here? I can see here. So this is what my equivalent circuit now coming. A and B. This is my R1 and this is my Ry now. What is Ry here? By replacing these two elements, Ry is nothing but R2 into Rx by R2 plus Rx. This is the what. Now again assume here. So current direction from A to B, A to B. So this is my current. I is going like this, like this, like this is coming. So same current is flowing through R1 and Rx elements here. So both are, I can take it as the series elements. So I can add both elements here, both resistance values here, and R equivalent can be sorry, this is not the inductance. It can be taken as this sum Rz is nothing but R1 plus Ry. So this resistance plus this resistance. So this is how you can reduce your this whole network into a single resistance value. So this is what the R equivalent concept you need to understand here. So this is the circuit has been given us and they are asking to find what is the total current is flowing through this circuit. So that is what they are asking to find here. So whatever the total current is flowing, what is I coming here, what is I? So this total current due to this source 12 volt source we are connected here. So due to this 12 volt source some current is flowing in all these elements and then coming back. So I need to find what is this total current here. So to find this, what I'm going to do is that I need to replace all these elements into a single resistance value, that is the equivalent of the resistance of all these elements. I need to do that one. So for that, what I'm going to do here is, so what I'm going to do is I will assign from this point. So assume this is A point and B point. This is the I current here dividing. Again, this current is coming dividing. Here it is something like this coming. This is what the current directions. If you see this one, right? So you start from this end of this network here. So at this particular specific network here, the branch here, 2 ohm and 4 ohm resistors are connected in series, because whatever the current seen by this resistance is same as this resistor. So I can take both resistor, I can as series and I can add them. Okay, so this is what I'm doing now. And this, then what is my representation of the circuit here? It's coming like this. So these two are added, and this is the 12 volts. 12 volts is there, 3 ohms, 8 ohms, 5 ohms and 6 ohms. But what about this one? This has replaced now. Adding R1 and R2, these are the series, so I can take 6. So this is the current directions. You can imagine here, and coming like this I current. Okay, now if you take this portion of this network and these two elements, the current has, this current has divided in these two elements, whatever this current is seen here also. So these two are now connected in parallel. So in the case of parallel circuit, what is equivalent? 6 into 6 by this 6 plus 6, you have to do this one, you will get 3 ohms. Okay, so this is what. Then what is the equivalent circuit? Again go back and redraw this one. If you redraw this one, and this is what you are going to get. This is what, 12 volts, 3 ohms, 8 ohms, and this is what, 5 ohm, and replacing this is coming. So this is what, 3 ohms. Now again we're going to see what is happening here. Now after this, again from AB terminal, again draw the current directions. So this is direction, this direction coming like this. So now I will take these two elements, then I can conclude that these two elements are connected in series now. So I can write 5 plus 3, that is 8 ohms now. So I can replace 8 ohms with these two resistance here. So then what is we are going to get here again? So this is what the circuit you are going to get: 3 ohms, 8 ohms, and this is what total 8 ohms. So this is equivalent circuit. So again do the same procedure here, and apply give the direction of current, and I can say that these two are connected in parallel. So my equivalent circuit is come like this, and this is what my equivalent circuit is coming. 12 volts is there at a B terminal. This is what the voltage source here, and this is 3 ohms. And what about this one? This is has been replaced. So what is this? This is 8 into 8 by 8 plus 8. So you are going to get, this is 4 ohms. So this is what 4 ohms are going to get, this one. Okay, once if you see again, this is the current I is going some same current. So this also can be represented here as a single resistance, that is 3 plus 4, 7 ohms. And this is what my AB terminal here, and my 12 volts battery is there, and this is my current I. Now what is the total current I? Is nothing but the 12 volts by resistance, that is V by R I am writing. So this is what my current. So this will come nearly 1.714 amperes. So this is. Now the question is that suppose the same circuit has been given, and now they are asking to find what is the current in the 8 ohm resistance. What is the current flowing through this 8 ohm resistance? Then also the same procedure you have to follow. This procedure you have to follow, and you need to find what is the total current. Once you are getting the total current here, so this is what the total current you are getting, and now I want to find what is this current. So which circuit I am going to consider is this one. So I can take this one, and I can find what is the current is flowing here in the 8 ohm resistance. So this is what the circuit. Now reduced circuit I have, and 12 volts, no, and 3 ohms. So I already know what is the current is flowing, total current 1.714 amperes. and this is what the 8 ohms and 8 ohms. Now I need to find what is the current is flowing in this resistance. I can say what in that this resistance I1 and I2, you can assume it. Then I1 can be written as, you apply the current division technique. Now apply the current division technique here. I1 is equal to the total current 1.714 into this resistance by the total resistance 8 plus 8. So this is the answer for this particular current which is flowing through this circuit. So like this you can find what is the current here also, and what is the current, and you can find what is the voltage, and you can also find what is the power at each and every element. You can do that analysis, can be done. So with this our Ohm's law, if you know the Ohm's law, KVL and KCL and voltage divider technique and the current divider technique, if you are well known or well understood by you, so you can do the any particular circuit or any network. From that you can calculate any parameters, is like the power, what is voltage, what is current, what is the resistance of any circuit. So these kind of parameters can be done. So with that we'll stop this session today, and the next class we're going to see what is the different analysis is called nodal analysis and mesh analysis.